Now that you've seen the two kinds of problems concerning the normal curve, your goal is to be able to read a problem and decide whether you're going to use normal CDF or inverse norm. So I challenge you to pause here and do the next two slides and then come back and watch and see if you got them right. Tall Clubs International has a requirement that women must be at least 70 inches tall. Remember that that means 70 or more inches. Given that women have normally distributed heights with a mean of 63.8 inches and a standard deviation of 2.6 inches, find the percentage of women who satisfy that requirement. Always look and see what you know. Mu is 63.8, sigma is 2.6. I can label the normal curve that's on my slide. 63.8 goes in the center where the mu is. And when I look back at the other piece of information in the problem, at least 70 inches, I know that that inches is also going to go on the horizontal axis, which in this case represents x's. And since 70 is bigger, we go to the right, somewhere off to the right of 63.8 and label the 70 inches. Since it's 70 or more, at least 70, we would shade to the right. And we now have a shaded area with a lower boundary, and then our upper boundary is going to be the 9s. And because we have those numbers on the axis, then we're using normal CDF from 70, comma, to 9999, comma. Mu is 63.8, sigma is 2.6. You type that into your calculator, hopefully you already have, you get 0.0085. Go back and look at your original question that asked for a percentage. Move the decimal 2 places. We still have a really small number, 0.85%, but that makes sense because we know that the number of women who are over 70 inches is going to be a very small number of people, so a small percentage. It also matches with the small section of the graph that you shaded. Let's look at the next question. When designing aircraft cabins, what ceiling height will allow for 95% of men to stand without bumping their heads? Let's think about that for just a second. If they can stand up without bumping their heads, that means they are shorter than the ceiling, lower than the ceiling. We want 95% of the men to be lower than the ceiling. Men's heights are normally distributed with a mean of 69.5, standard deviation of 2.4. So mu 69.5, sigma 2.4. Label your graph in the center, 69.5. And then go back and think about the 95%. Is it going to be along the axis? No, it's not a number of inches. It's a percent. Percents are always inside the graph, which means we're going to use inverse norm. Remember back when we were doing these examples, you can think about the normal curve as 0% on the far left, 100% on the far right, going from left to right. If we're filling up 95%, it's going to be pretty far to the right, so pick a point. And then again, because we are talking about shorter than that, a height of ceiling where 95% of the men are shorter, they don't bump their heads, then that's going to be to the left. And remember that inverse norm uses the area to the left, so 0.95. Mu is 69.5, sigma is 2.4. When you type that into your calculator, you should get 73.45 inches. My screen is auto-saving, so just hang on, and there we go.